So thank you very much for coming. This presentation is to show the winners of the Hacker House. They worked very hard on this. It was an amazing moment for all of us, for the startup ecosystem. It has been the biggest Hacker House we have ever had, not only in startup, but to my knowledge, in the entire Layer 2 ecosystem. So congratulations of that. Some statistics. We had 25 projects that they work on during the weekends. It's amazing. 80 hackers from from 4 different continents participating. So we had a huge diversity in ideas, in concepts. It was amazing. Several projects working on cool stuff, for example, in Bitcoin, in zero knowledge technology, and machine learning. So it was very, very, very interesting. Some photos of the event. We enjoyed a lot. It was brutal. It was interesting. Everybody was happy, tired, but happy. And now it's time to see the results of it. So without further talking about this, let's see the presentation of the winning teams. First, we have Parjut and Raf Su. I don't know if you have a name for your project. Do you have a name for the project, or
Sorry?
is there a name for the project, or?
Yeah, so the project is called NAPA. So it's a sort of on-chain options derivative exchange that we built on the Madara app chain stack, mostly as an exploration of Madara. But yeah, that's the project. Are we presenting now? Yes. Okay. So yeah, maybe just to rewind a bit here. So yeah, nice to meet everyone. So I'm Park. I'm actually the founder of a AMM project on Starknet called Sphinx. And then my teammate Rafa, who was actually my roommate during the Hacker House, we decided to hack together, is a math and CS major at Brown. So I guess, yeah, I'll pass over to Rafa to explain the project.
You met during the Hacker House? Yeah, we met like 4 days ago. Yeah, my name is Rafa. So for our project, the basic utilities that we allow people to buy and sell calls and puts. So what calls and puts are, basically they are financial instruments for traders to gain single-sided exposure to underlying price movements. So let's say your price is going up, then you can put in some little money, but you can get very good upsides. For a put, is that when a price is going down, you can also put in some little money. When price goes down, you get very good upsides. Many people think about these instruments as only buying them, but in fact, there's also a selling aspect of that. That's what Goldman Sachs in equity market does. What we're trying to do is to allow all these 4 combinations strategies. With these 4, basically, people can achieve 2 goals. They can do hedging and trading. Hedging means you buy an asset, you get exposure to a bunch of factors, and you don't want to get exposed to certain factors. Let's say you are buying BTC, and then you're trying to hedge against that risk a little bit. Then you do hedging by getting some puts when you are buying something, right? And that will be a pretty covered position. For trading, it's basically you put in some committed capital to gain a bigger upside using options, or you can trade on volatility, meaning volatility will change and then option price will change in a different way, and then you're trying to gain that factor exposure as well. I'll hand it to Park to talk about specific implementation.
Yeah, just to provide a bit more context on what we actually built. So the core protocol was NAPA. So this is a options derivative exchange, meaning it's cash settled. So buyers and sellers are never required to hold the underlying assets. Everything is settled in cash. And so to enable that, we had to build 3 major components. So one was the sort of matching engine that allows buyers and sellers to be matched and to exchange that exposure. We chose to use an order book implementation here with kind of a double-layered linked list for efficiency. We prefer that over kind of tree-based approaches to limit the number of storage rewrites here. The second aspect was the liquidation engine. So again, because this is a cash settlement protocol, we need to monitor user positions for liquidation. So whenever the value of the position falls below committed margin, it needs to be liquidated. And so that's the second aspect. And then third is the kind of cash accounting to enable deposits and withdrawals and to maintain the required margin. So all of this was written in Cairo, which was a great way to kind of get deeper into the language. So it's like Rafa's first time writing Cairo, which is great, just learning more about the VM. And then on top of all this, we deployed this onto the Madara stack. So for those who don't know, Madara is an SDK essentially for deploying an app chain. So you just drop your deployed or your compiled Cairo contracts into this repo, and then you can deploy as an app chain, which is really cool. Yeah. So just to expand on this, this was really the purpose of the project, to explore using Madara and the Starknet stack. So what we sort of found was there were a couple of really nice features which makes this worth exploring, and I would urge everyone to try it out for themselves on their projects. So one was it's really highly customizable. We were using this AppChain SDK to try to achieve two main goals. One was to have free order placement and cancellation. So an example here is we were able to do that in sort of like under 10 lines of code. So disabling gas fees, we were able to adjust block times to allow for really fast throughputs. And then the kind of main benefit of using Madara is they just released a new AppChain template. So it was really easy to deploy. We could just drop in our Cairo code onto the repo and again, just deploy as is. The third thing is Madara is really designed to be interoperable with the rest of the ecosystem. So it's built on Substrate, meaning all of the palettes are reusable within that ecosystem. But also there's other kind of core companies like Pragma, Herodotus, building infrastructure for app chains. So from bridging to storage proofs and so on. So it's really designed to plug into the rest of the ecosystem. And yeah, just to reiterate, it kind of works with Cairo out of the box. You can focus on writing Cairo code. So these are the two repos we wrote. Feel free to check them out, and maybe stars on GitHub. And you can follow us on Twitter. And these are also our respective projects. So again, I'm working on an AMM project called Sphinx. And Rafa is working on a project called Sparrow Swap. Thank you.
Thank you very much. So they met at the Hacker House, and first time writing Cairo code, they won. So congratulations. Now let's go to the next team. This we already see. Team number 2.
Hello everyone. Today we are going to present you the project we work on what we work on during this Hacker House, Bitcoin GA. A big thanks to all the staff of the Hacker House. And just a quick presentation. This is Ethan Levin. I'm Axel Isaac. We are both developer at Khazard Square. It's a dev shop on Starknet. We do a lot of cool things. Now let's dive in.
Yeah. So hello everyone. So Bitcoin DA basically is the name of a library we wrote in Rust, which allows us to use Bitcoin as a data availability layer. It means that when you have your own rollup, you can write your data on Bitcoin blocks and then read them back after. For example, you can write state diffs or just transactions, whatever you want. We wrote it in Rust because we know that Starknet community loves this language, and us too. We are currently coding in Rust. And also because we wanted to integrate it to Madara Stack. So I wanted to explain a little bit, but I know that the other group did it some way. So what we were interested in, what was interested in Madara is that 2 weeks ago, a new crate was implemented in Madara Stack, and it's the data availability layer in Madara. So Rust trait allows us to implement the Bitcoin trait as a data availability layer. So with our custom the Bitcoin client and our configuration. And with this, you can easily write state diffs when you produce blocks with Madara. So this was the big part of what we did at the Hacker House those last days.
So Bitcoin DIA is write in Rust, and it's also open source. So if you want to integrate it to any, you can integrate it in any sequencer with write in Rust. So just try and enjoy it. We do also some wizard experimentation with the Taproot Wizard team about Bitcoin and Starknet. This is just the first step of a bigger project. And we are in the process to open sourcing all the code. So just stay tuned on Khazar Labs Twitter, and more info coming soon. Now let's see a small example of the code.
So this is an example of the write function. You see that the write function only takes in input some bytes of your data you want to write on Bitcoin blocks. So there is at the right code example. You just have to cast a Bitcoin client into a relayer, and with RPC port of your full node, and the write function will just create a taproot address and then commit the transaction with fees, and after you can just post your data and get the ID of your transaction. And if you store it, you can, we imagine that you can retrieve it with the retransaction function we also implemented in our repo. And so it allows us here to use Bitcoin as a data availability layer for any app chains on Starknet.
Thanks a lot. And if you are a developer and you want to take part of the Starknet ecosystem, you can reach us about Khazar Square. Thank you.
Thank you very much. It's important to mention that there's no order of winners. These 4 winners are equally okay. It's not number 1, 2, and 3, 4. Then we have very unique and Josh Klopp.
Hey everyone, my name's Neil and this is Josh. We're software engineers from Nethermind, and at the Hacker House we built a Cairo ABI gen tool. So basically when you write a Cairo contract and you compile it, you'll get an ABI or application binary interface. And this is a JSON file that documents how you would interact with the smart contract. So it includes things like the input data structures, outputs, the methods that the contract has, and so on and so forth. And currently, the way that a user would interact with the contract is that they would have to serialize the inputs, such as the entry point selector, build the JSON RPC request, deserialize the outputs, and all that networking crap. And so what the ABI gen tool does is you will input the ABI, and it will generate a Golang library that will allow you to more easily interact with the contract, which Josh will explain now.
Yeah, so as Neil covered before, it was quite painful for dApp developers to interact with Starknet contracts. And the long-term goal of this tool is to allow seamless development by providing static types and enabling you to take advantage of superior development tooling like language, all the goodies you get in VS Code or any other editor with like the language server protocol. And it allows you to check to get errors at compile time. So if you have a Go program that needs to interact with a contract, instead of having some string that can break at runtime if the contract changes, you can just generate the bindings to the contract after you compile the Cairo contract and before you deploy it, which gives you that compile time error checking. An example of what this looks like, at least from our preliminary work in progress, here's a struct from an actual Cairo ABI, and the result, so this is the struct from the ABI, and then the result after running this ABI through our tool is this struct that can be, this Golang struct that you can import into your project and and you'll get static, all the goodies of static type checking when you use this tool. So yeah, it's really that simple. If you have any questions, happy to talk and collaborate on how we can make this even better. Long-term goals would be enabling you to call the StarkNet contract directly. For example, filter events that are emitted from, over multiple blocks, and maybe even simulate transactions against the contract. The sky's the limit when it comes to this. So yeah, a big thank you to the Hacker House for hosting us, and also a big thank you to the Go Ethereum ABI Gen tool. That was a big inspiration for this. It does has very similar functionality for Solidity, and we just want to bring that same functionality to SnarkNet and Cairo. Yeah, thank you very much.
By the way, I was a little bit pressed because of time, but now I realize we have more time than I expected. So, any questions to any of the winning teams until now? Is there any question for any of the teams? Yes?
Yeah, the question was how to monetize this ABI Gen tool. I would say that this is more of a public good tool. It could be easily incorporated into an open source project that might be able to get funding some other way. But it's a good question. If you have any ideas on how we could fund open source projects, I'm definitely all ears. But I'm not sure that this is the best product to monetize. Yeah.
Perfect. Any other question for any of the other teams that already presented? Yes.
So I think I'll answer the second question first because I can't quite remember the first one. So I think the second one was around how do you manage risk because it's all on chain. So yeah, so for this demo, we were more focused on the Madara integration side. So actually we made a lot of simplifications on the actual protocol itself. So for example, for liquidations, all we did was, when liquidated, transfer the position to the contract owner rather than actually liquidating through the order book or offering, incentives for third parties to liquidate the position. But of course, like in production, you would have to go with either one of those options. I think, for example, like Avo, they liquidate through the order book, and then there's a sort of like insurance fund. So that's one model, but there's other ways you could do this. I think do you mind repeating the first question? Just. Right. Yeah. So at the moment that's on chain. Basically, you set an expiration timestamp. I would say maybe there's a attack vector there where the sequencer could manipulate the time. So potentially you could get around that by using a block number instead. But for the demo, we use a timestamp. Yeah.
So we'll continue with the questions in a minute. Let's go with the last winning team, and then we can go on with questions. Zion Darko, please.
Hello, guys. So my name is Zion, and this project is Oneiros. So Oneiros, we create digital identities for users to control their data and unlock the full power of the internet. So right now, your apps online contain data about you, and these are on different apps online, so it could be social media, games, Amazon, retail, etc. And what we do is we train AI models that learn from all your data sources to basically reflect you digitally. So it'll be your digital personality, your digital identity. And then you can use these digital identities to interact with other apps online, to earn rewards, to control your data, and most importantly, to get enhanced content and optimizations. So I'll actually show you the app instead of explaining it. Oh, how do I? Can I? I sent you the videos on Telegram.
Can we stop sharing the screen just a second, please? Yes. And maybe we can go with another question in the middle. We will show a video, but we need to load it. No sound, it's okay without sound. Thank you, thank you. I don't know if there's any other question for one of the winning teams. For example, the Bitcoin DA team. Anything else? Another question? Can we share again the screen, please?
Thank you. So I'll just restart it first. So your digital identity comprises of two things. It's an avatar and a digital personality. So your avatar you can create to look like you, and you can use that for digital mediums like social media, AR, VR, etc. But the real beauty of Anaros is your digital personality, which I'll show you now. So you're going to see we're able to connect different apps to create your account, your model. What this means is that you can create apps, you can connect apps like Instagram, Pinterest, Reddit, basically any app you have. And what we will do is we'll take the data from these apps and train an AI model to learn how you think, how you behave, how you act, what you like and what you dislike. And the integration is very easy. The same way you log into Google or Facebook, you just log into Reddit, click allow, and we instantly have access to your data through your authorization. And now, once you created your model with simple clicks, you can then use the Anaris account with other apps. So this is an example of how you'd use your Anaris account with a bookstore. So you see an initial selection of books that this bookstore presents to you, and you may or may not be interested in it. What you can now do is you can connect your Anaris account, and you can control the data you send to this bookstore so that they can optimize and personalize your experience online. One second, the videos. Video's not playing. No. 1 second. Okay, yeah. Yeah. So if you see here, you can control the type of data you send from your model to this bookstore. And if you don't want to send any data, you don't have to send any. And they give you a reward in exchange for the data you send. And now they are optimizing your experience based on the data that you sent them. So you'll see in a second that the books that are displayed will change. And what this means is that this bookstore now thinks that the selection that they're going to present to you is something that would interest you more, maybe books that you'd be more interested in buying or looking at. And this is just an example to show you where you could have social media optimizations, game optimizations, retail apps, Amazon, Google, etc., ads, dating apps. And now I'll explain how we leverage the Starknet ecosystem. So we utilize Caro and Giza. So once you've created your models and you want to use it and send the data, we first use the Giza CLI to convert your models into Caro 1.0 programs. We then use Orion from Giza again to run the machine learning inference of your model to get the model output. And then once we have the model output, we use a Stark prover like Stone or any other Stark prover that's compatible with Caro programs, and we generate a ZK proof. And what this proof does is we send this with the data to the app that you sent the data to, and the app can then verify that the data they have received is valid for the model and that there was no tampering with the machine learning. And we do this because if we do not send them a ZK proof to confirm the data, they would have to look at your user models, and of course that is invasion of privacy, which we are not going to do. So we send them a ZK proof and the data so that your models are always hidden. Brief benefits to both parties, apps and users, is consensual data access, optimized experiences, better ads, filtered content, more complete profiles. You can save time, many benefits to different apps that you can interact with. yeah, some traction things, but I think time-wise, yeah, we'll just skip that. Yeah, thank you very much.
Thank you very much. That's all the projects we have. Is there any question for our projects? Is there any question to any of the projects right now? No? Okay, then I want to thank everybody. I want to thank the Hacker House. Now let's connect in Dev Connect in Istanbul. We might have something else. So we're expecting your applications for the next Hacker House, and this one was amazing. The next one is going to be even better. Thank you very much. Congratulations, all the winners.